In today's lesson, we are going to be looking at solving one and two step equations. So these are going to be the most simplest equations that we kind of come across. Some of these you might be able to do in your head. Some of them you might be able to do very quickly, which is okay. If you find them a little bit challenging, that's fine as well, right? You might not have looked at solving equations before. I will say though that you should be showing your work for definitely the two-step equations. The one-step equations, you'll see that as we get into them, you might not have to show your work because you might look at the question and be able to get it. But for the two-step and above, you should be showing at least one piece of work or one-step work. And again, I'll go through and show you that. So previously, we have looked at kind of the Solve Me mobiles, or the mobiles where you're given a mobile and you have to find the missing or the value of the missing shape. Now, the idea is if we look at the mobile, we can see that they are balanced. So because they're balanced, that means the one side has to equal the other. And so we've looked at these examples you had to go through and solve. We're going to look at how to do them or write this in a mathematical form. So here we have an unknown. We have this shape, this trapezoid, that's an unknown. We don't know what that value is. And in math, when we don't have a value for something, we use a variable. We use a letter. So I'm going to use an x. Now the heart I know is equal to 2. So that means an unknown plus 2 has to equal 3 hearts, or 2 plus 2 plus 2, which is 6. So an unknown plus 2, or x plus 2, has to equal 6. Well, what could that be? You might be able to look at it right away and say, well, that has to be 4. So x has to be 4, and you would be right. X has to be 4. That is our solution. So let's go on and move to the next one. I have four circles. I know each circle is 4 because the diagram or the legend tells me it is. So 4 circles, so 4 plus 4 plus 4 plus 4 is 16, is going to equal 1 circle, or 4, plus 2 unknown triangles, or 2x, right? One unknown plus another is 2, or 2 unknowns, so 2x. This one might be a little bit more challenging, right? You might be able to say, well, in the mobile, I'd say, well, I get rid of 1. Let me use a different color so it shows up a little more. I get rid of 1 circle, I get rid of 1 circle. That would leave me with 12 is equal to 2x. Well, what did we just do? Well, we canceled out the 4 on this side and canceled out 4 on this side, or subtracted 4 and subtracted 4. The 1 cancels out, disappears, and 16 minus 4 is 12. Then now what do we do? Well, if the 12 has to be divided up evenly into 2 groups, or 2 x's, that'd be the same thing as saying, well, I can divide both parts by 2 and see what we get. Well, 6 equals x, and that works out to our solution. So you might be able to do that in the mobile. Mathematically, this is what you're doing in your head. You might not think of it as this, but this is what you're doing. Now let's kind of go in the other direction. Right, we have our mathematical expression. Let's draw this as a mobile. So I have 3 plus 2x. So I'm going to have one shape representing 3, and I'm going to have 2 squares representing x. On the other side, I have 15. So I could represent that as just one shape with 15, or I could do 5 circles and say that each circle is equal to 15. And then the square is unknown. So what would we do? How would we solve this? Well, thinking back to the last example, let's get rid of the 1 circle on this side and then 1 circle on this side. So I would get rid of the 3 here. I would take away 3. I would take away 3 from this side. I'm left with 2x is equal to 12. Visually, it's a lot easier because I can say, okay, well, these 2 circles go with this x. These 2 circles go with this x. Or essentially what I've done is I've taken the 12 and divided it into groups of 2. and that will tell me what x is. In this case, x is equal to 6. Last example, 5y plus 4 equals 9. So if I want to draw this to mobiles, I have 5 unknowns, so I'll do boxes again. So this one isn't the nicest to draw out, but 1, 2, 3, 4, 5, 6, or one too many. So 5 boxes, which will act as my unknown, or my y's. I have 4, so I'm going to do a little bit different. I'm just going to do a group of 4 small circles. And on the other side, I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9. So each circle is equal to 1 in this case. So what would I do? Well, similar to what we've done before, if I'm trying to find out what each box is, let's get the boxes by itself. So let's get rid of these 4 circles. To keep it balanced, though, I need to get rid of 4 circles on the other side. So what I've done is I've taken away 4 from the one side, I've taken away 4 from the other side. I'm now left with my 5y and just 5. Visually, it's a little bit easier to see because I can say, okay, well, this box goes, oops, if I'm trying to find out what each box represents, well, this box is just to this one. There's one box for every circle. And if each box is equal to 1, or each circle is equal to 1, well, then it's the same thing as saying just 5y divided by 5, and 5 divided by 5, and dividing that group of 5 circles up into 5 groups of boxes, so to speak. And we have y is equal to 1. So these two examples that we looked at, these are examples of one-step and two-step equations. And in general, what we've been doing is we've been using opposite operations to cancel out terms. Right? So the whole idea of solving an equation is to basically find what is that missing value, what is that unknown value. And to get that value by itself, we've been using opposite operations to cancel out terms. So for example, when you have addition, the opposite is subtraction and vice versa. When you have multiplication, the opposite is division, and again, vice versa. Some other examples you might see, right? The squaring something is the opposite of square rooting something. Those are really the only examples we're going to be kind of going through or operations we're going to be looking at in this course. So the opposite of addition is subtraction. Opposite of subtraction is addition, multiplication and division are pairs, and squaring and square rooting are pairs as well. The other thing that we want to keep in mind is we want to keep our equation balanced. Similar to that mobile, if we do something to one side, we have to do it to the other. Right? It needs to remain balanced, or in other words, we need to keep our equation the same. Right? If we only do something to one side, that's changing the entire equation. But if I do it to both sides, that's keeping it the same. So let's look at the following one-step equations. X plus 5, oops, this should be equals 13. So x plus 5 equals 13. So this is a one-step equation, and it's called a one-step equation because there's only one step that we need to do to solve it. Now you could look at this and say, okay, well, something plus 5 equals 13. Oh, I know what it is. Right? And write down the answer, which is fine for the one-step equations. If you don't, if it doesn't come to mind right away, think about, I have an unknown, I add 5 to it, and I get 13. Well, if I want to basically find out what that unknown is, I want to get rid of this plus 5. So I get rid of this plus 5, I do the opposite. I take away 5. To keep things balanced, I need to do the same thing to the other side. Minus 5 from there. These two cancel out. Let's keep it in red. These two cancel out because add 5, take away 5 is 0. 13 minus 5 gives us 8. The only thing left on the left side is x. So I get x is equal to 8. which makes sense because 8 plus 5 is 13. You might have jumped to 8 right away, which is fine, and just wrote down x equals 8. Again, that's fine because you don't need to, there's really only one step. So because you can do this in your head, you can just write down x equals 8. Let's look at the next one. Y minus 6 equals negative 17. Looks a little bit more complicated because of the negatives. We do have a y, but that's okay. It's still an unknown, so the letters can change. The steps are going to stay the same. So if I want to get rid of minus 6, the opposite of taking away 6 is adding 6. So if I add 6, that would cancel out, but I need to keep it balanced. I need to do it to the other side as well. I'm left with y is equal to negative 11, which is my final answer because y is now by itself, y equals negative 11. It's a little nicer. You could jump to that right away, right? And again, just write the answer. That's fine for these types of questions. For C, negative 7 times A equals 63. So negative 7 times something equals 63. If we don't know what that value is, we can cancel out the multiplying by doing the opposite operation, which is division. So the opposite of multiplying is dividing. I'm going to divide by negative 7, and I'm going to do the same thing to the other side. Now, one thing to keep in mind, right? We don't change the sign. It stays as a negative 7. We're not changing the sign when we do this. We're changing the operation. If we look at these two, it looks like we're changing the sign, but we're not. We're actually changing the operation. So just be mindful of that. You're not changing the sign, you're changing the operation. So the negative 7 times A, we cancel that out by dividing by negative 7. These two cancel out. I'm left with A, or negative 7 divided by negative 7 is 1. 1 times A is still A. On the other side, 63 divided by negative 7 is negative 9. So that is my final answer. Again, you could have jumped to that. You could have looked at, okay, negative 7 times what? Well, I know 7 times 9 is 63. Negative 7 means it has to be a negative 9, and there's my answer. That's okay as well. For D, k over 3 or k divided by 3 equals 12. How do we cancel out dividing by 3? Well, we can cancel out dividing by 3 by doing the opposite, which is multiply. So I'm going to multiply by 3 on the one side. I'm going to multiply by 3 on the other side. When I multiply by 3 and divide by 3, they cancel out. I'm left with k. 12 times 3 is 36. So 36 divided by 3 equals 12. Yep, that makes sense. That works. That's my unknown value. Again, you could have jumped to that without having to show this work, which again, for one-step equations is fine. Now, one-step equations are pretty simple. Like I said, you could have looked at all of those and got it right away. Two-step equations are a little bit more challenging. Those were some of the second examples that we looked at in the mobiles, and this is an example of a two-step equation here. Two-step equation, it's called that because there are two steps. Right? Not very creative, but it makes sense. So there's two steps or two things we're going to have to do. And this is going to be probably the most common equation that you're going to see in this course because it does come up quite a bit in the linear relations, which is our next unit. But the one thing we want to do, we look at this, we want to get x by itself here. There are two numbers that we need to get rid of, the 4 and the negative 15 or the minus 15. So the only challenging part here becomes which one do I get rid of first? And I'm going to tell you that you have to cancel out the non-variable term first. So you have to get rid of the minus 15 first. And if you did the mobiles at the beginning and then that little warm-up, if you did that, you would have canceled out the non-variable term first. And that is what you're going to be doing here. So we're going to get rid of this minus 15 first, right? Non-variable just means the term without the letter, right? So the minus 15 does not have the letter. That's the non-variable term. That's what we're going to get rid of first. And as you do more of these, you'll start to see kind of a you'll start to kind of see a pattern in the steps that we go through. So let's look through and solve these following two-step equations. So for the first one, we already mentioned we want to get rid of the minus 15 first. Well, how do I get rid of minus 15? Well, I have to add 15. So if I add 15 to the one side, I have to add 15 to the other side. And when I talk about one side or the other, I mean the other side of the equal sign. So if it helps, sometimes you might want to draw maybe an imaginary line down the middle. So you know, okay, well, I have a plus 15 on the one side, I have a plus 15 on the other side. Good, things are balanced. One side will cancel out, which is good. That's what we want. We're then left with 4x is equal to 36. So now we're down to a one-step equation. So 4x equals 36. Again, you could look at this one-step equation and say, well, x has to equal 9. If you're not sure, 4x. That's 4 times x. So that means to cancel out the 4, we have to divide by 4. Divide by 4 on the other side. One side cancels out, and we're left with x is equal to 9. Now, this is an example where I should see multiple steps, right? It's a two-step equation. You might be able to do in your head, but I should be seeing some work. So in the last one, all I really need to see was the answer. In this one, I need to see some steps in between, right? So I should see at least this beginning portion, then this one-step equation, and then the answer. So really, I should see the step to convert to a one-step and then the answer, at least. And so just keep that in mind as you kind of go through. If you want to show all the steps just to keep consistent, that is fine as well. For the next one, 13 equals negative 5k minus 7. So again, I want to cancel out my separate term, which is this minus 7. So to cancel out minus 7, I have to add 7. I need to do the same thing to the other side to keep it balanced. So I'm going to add 7 to the other side. I'm going to draw this line down the middle just so I can kind of have that as a reference. You don't need to do that if you don't want, but again, it's up to you. If it helps it makes it easier to see what do I have to do. Have I balanced things out? Then by all means, draw a line down the middle. The one side will cancel out. I'm left with 20 is equal to negative 5k. So negative 5k is the same thing as negative 5 times k. If I want to cancel that out to get k by itself, I'm going to divide by negative 5, not multiply, right? Or not add, because the operation that's going on is multiplication. So I'm dividing by negative 5. I'm going to divide the other side by negative 5. One side cancels out. I'm left with k is equal to negative 4 as my final answer. Now, if you prefer having the unknown on the left side, you can take this equation and just switch it entirely and say negative 5k minus 7 equals 13. You can just switch the left side and the right side completely, right? And that would still be the same equation. So if you prefer to do it that way, you're more than welcome to as well, if you prefer having the unknown on the left side instead of the right side. But either way, the steps should be the same and you should still get the same answer. Just 2 more examples. So again, I'm going to kind of go away from using the line down the middle, right? If you still need that, by all means, go ahead. But hopefully the goal is that you don't need to do that as you become more and more comfortable. So I have 4 plus 3x. I want to get x by itself, so I need to get rid of this non-variable term, the 4 first. So to get rid of plus 4, I'm going to minus 4. I'm going to minus 4 from the other side. One side cancels out. I'm left with 6 is equal to 3x. It's 3 times x, so I cancel the 3 out by dividing by 3. Do the same thing to both sides to balance. One side cancels out. 6 is equal, or not 6, sorry. 2 is equal to x. And that is my answer, or my solution. For D, I'm going to show a different way. Right? So one way to kind of show your work and to kind of work through these steps is by canceling out terms, similar to what we've done. For D, I'm going to show you a different way. This is a way that I prefer to do it, but again, it requires kind of like an inherent knowledge of what we're doing, right? So I have minus 4n plus 2 equals 14. So another way you can think of it is, well, I want to get n by itself, so I want to move everything away. So if I move the plus 2 to the other side of the equal sign, because it's away from the n, it becomes the opposite. So instead of plus 2, it becomes minus 2. So then I'm left with negative 4n equals 12. Well, I have a minus 4 times n, so if I move it to the other side, it becomes division, which becomes 12 divided by negative 4, and n equals negative 3. So it's a different way of thinking about solving the equation. It still is the exact same thing, because if I take this, just kind of bring it off to the side and do a separate one in purple, right? We cancel out, we minus 2, oops. We minus 2 on the one side, minus 2 on the other side. One side cancels out. We're left with minus 4, n is equal to 12. We divide by negative 4, divide by negative 4. One side cancels out. I'm left with n is equal to negative 3. It's the exact same thing, right? You might do some of the steps kind of in your head when you're moving things across, but in the end, you still get the same thing on both sides. The last thing we want to look at is checking your solution. So in checking your solution, this is a way that you could always check your answer to see, did I get the right answer? So when checking, you want to check to make sure that the left side equals the right side. And we'll talk about that. But if the left side equals the right side, you have the correct solution to make the equation balance or to make it work. And what you do is you plug your solution or your answer into both sides and solve. So let's check our solutions from A and B from example 2. So if I scroll back up, I had 9 and negative 4. So here I had x is equal to 9 and k is equal to negative 4. Was it negative 4? Yes, negative 4. So what we can do is I'm going to take this answer and plug it back into the equation. So it's going to be 4x, or sorry, first what I'm going to split it into a left side and a right side. So the left side of my equation is everything to the left of the equal sign. So 4x minus 15. The right side is equal to everything on the right side of the equal sign, or just 21. So and then I'm going to substitute in x equals 9, wherever x is. On the left side, I can do, say, 4 times 9 minus 15. The right side stays 21. There's nothing I can plug in there. It's just 21. Here I have 36 minus 15. I can continue to simplify, and I get 21. So the left side simplifies to 21. The right side is still 21. So left side does equal right side. So that means I have the correct answer. If they didn't equal, then we would have something separate, or that means, or if they didn't equal, we have two different numbers. That means my answer is wrong. So I'd have to go back and try to resolve. Let's do the same thing for B. Left side is 13. That's good. I don't have to simplify any further. The right side is negative 5k minus 7. I'm going to go through and plug in negative 4 for k. So negative 5 times negative 4 minus 7. I get 20 minus 7, which is 13. Looking back, okay, left side is 13, right side is 13. My left side equals the right side. Good. That means I have the correct solution. If I had something different, my solution for k is possibly wrong. Maybe I made a calculation error, but chances are calculations are relatively straightforward. So that means my k value would have been wrong and I'd have to go back and resolve. So this is a good way for you to always check your work, right? So you can always go through and check your work, check your solution. So if you don't have an answer page or an answer sheet, you can always check your work and just check by plugging it back in and seeing, do I have the right answer? So this will be helpful on like quizzes and tests and assignments, because it's a way to always see, do I have the right answer? But the main thing is, again, aside from checking your work, looking at 1 and 2 step equations, right? Again, these are the basic forms. Practice does really help with these, just kind of going over and over multiple examples. So you start to see kind of a pattern, start to kind of get used to the opposite operations, the balancing, those 2 steps in solving equations. And we will kind of be always coming back to those 1 and 2 step equations, opposite operations, and balancing when we look at some of the more complex ones later in the unit.